Hello everyone, welcome back to the channel. In the previous video, we learned what work is and also understood 1 joule of work with easy examples. Now, before we move to the next topic, let's learn one more important concept. Sometimes instead of giving the value directly, a question gives us a force displacement graph. In this graph, force is on the y-axis and displacement is on the x-axis. The rule is very simple. Work done is equal to the area under the graph. Let's take this example. The force is 10 Newton and the displacement is 1 meter. The graph forms a rectangle. Area of rectangle equal to length into breadth. So, work done equal to 10 multiply 1 equal to 10 joules. Remember this important point. For a constant force, work done is always equal to the area under the force displacement graph. Now let's see, when does work done become 0? We know the formula, work done equal to force into displacement. So work done becomes 0 in 3 situations. First, when the applied force is 0. Second, when the displacement is 0. Second, when the displacement is 0. And third, when the force and displacement are perpendicular to each other, that is 90 degrees. Now let's understand 3 conditions one by one with simple examples. Now let's understand the first condition. If no force is acting on an object, then the work done is 0. Why? Because the formula is work done equal to force into displacement. If the force is 0, then W equal 0 multiply S, where S is displacement, that is 0. For example, imagine a football lying on the ground. Nobody is pushing or pulling it, so no force is acting on the ball. Therefore, the work done is 0. So remember, no force means no work done. Now, let's move to the second condition. If a force is applied but the object doesn't move, then the displacement is 0. And if displacement is 0, the work done is also 0. The formula is W equal to F multiply 0 equal 0. A simple example is pushing a rigid ball. You apply force, but the ball doesn't move. So displacement is 0. Therefore, the work done is 0. Remember, force is present, but there is no displacement. Okay? Now, let's understand the third condition. Sometimes the force and displacement are perpendicular to each other. I already taught you that F is equal to W equal to force into displacement. That means they make an angle of 90 degree. In this case, the work done is 0. For example, a girl is carrying a heavy box while walking on a flat road. The force is acting upward because she is holding the box, but the displacement is forward. So, force and displacement are at 90 degrees. Therefore, the work done by the force is 0. Remember, force perpendicular to the displacement means 0 work done. Now, let's quick revise all the cases. Case 1, force is present, displacement is present, but force and displacement are perpendicular, so work done is 0. Example, a person carrying a heavy box while walking. Case 2, force is present but displacement is 0, so work done equal to 0. Example, pushing a wall that does not move. Case 3, force is 0 but displacement is present, so work done equal to 0. Example, an object moving in outer space without any force acting on it. Now case 4, force is 0 and displacement is also 0, so work done equal to 0. Example, a person standing still with luggage. These are the 4 important situations where work done is 0. Now, let's study positive work and negative work. Work done depends on the direction of force and displacement. First, positive work. When force and displacement are in the same direction, the work done is positive. For example, when you push a cart forward, the cart moves in the same direction as the applied force, so the work done is positive. Now, negative work. When force acts in the opposite direction of displacement, the work done is negative. A simple example is applying brakes to a moving car. The car moves forward, but the braking force acts backward. Since force and displacement are opposite, the work done is negative. So remember these two simple rules: same direction equal to positive work, opposite direction equal negative work. That's all for today's lecture. In the next video, we will solve important numerical problem and practice question based on work done. Thank you for watching. See you in the next video.